Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
So for this topic, topic 1.5, determining limits using algebraic properties of limits, I'm just going to jog your memory with a couple examples. Don't let the letters overrun you. Just an example. So limit as b, x approaches c equals b. Just use some numbers real quick. So limit of 2 as x approaches 6 would equal 2. So I have a graph showing that. So no matter where you go on that graph, y equals 2. So it's just a horizontal line. So that x equals 4, x equals 5, 6, 7. It's always 2. Next, going to have limit x as x approaching 3 equals 3. And so the function x is an increasing linear function. And so no matter where you go, f of 1 is going to equal 1, f of 2, 2, f of 3, 3, so on and so forth. And for our third example, limit is x squared, x approaches 3 would equal 3 squared, which equals 9. Then just have the different formulas. I won't go over the formulas. Feel free to pause it and look over it. Next is our first multiple choice. So for what values of x does f of x equal 3x squared minus 5x minus 2 all over x squared minus 7x plus 10 have a removable discontinuity? So first what we're going to do is we're going to factor. So that'll factor out into 3x plus 1 times x minus 2 all over x minus 2 times x minus 5. So our discontinuities are going to be x equals 2 and x equals 5. However, our removable discontinuity is going to be x equals 2. Because the top x equals minus 2 and bottom x minus 2 cancel out, therefore that is our removable discontinuity. So our answer is A. Now 5 still is a discontinuity, just not a removable one. So here's a graph showing that. And to find the position of that hole on the graph, just plug 2 into the original f of x function, and you'll get negative 7 over 3, which is where the hole is. And that x equals 5 is still there. It's just a asymptote, that discontinuity. So now it's time for FRQs. The function k is defined on the closed interval negative 5 to 9. The graph of k consists of 2 line segments in a semicircle, as shown above. Let h be the function defined by h of x equals 1 to x k of t dt. For each of the following, find the value of state that does not exist. So for our first one, A, limit of k of x as x approaches 4 from the left. That's what that negative is there for. And so as we move along the x-axis to the right, going positively, we find that that value is going to be 0. X equals 0 right there at 4. But the value of k of 4 equals 3 because of that. There's a hole at x equals 0, and so the real value is going to be at that filled circle at 3. Letter B, limit of k prime of x as x approaches negative 2 from the left. That k prime, the prime, means slope. So as we're looking at the graph going from left to right along the x-axis, we're going to look at the slope. So that slope is going to be negative 2 over 3. Just the rise over run goes down 2 and then over 3. And our final letter C, limit as x approaches 1, k of x plus h of x all over ln x plus cosine pi x. So we'll just put 1 in for all of those. So k of 1 plus h of 1 all over ln 1 plus cosine pi of 1. So our first one is going to be k of 1. And looking at the graph of k, k of 1 is 3. So we'll just 3 plus, and then our h of 1, which is going to be our, it'll be that function, the h of x equals 1 to x, k of t dt. So you just plug 1 in for x, and 1 to 1, there's no width there, so it's just 0. And then natural log of 1 is 0, and then cosine of pi is -1. So that'll equal 3 over -1. That equals -3. So that is our answer.